Can I turn off the light?
Today, we're going to be teaching you about conic sections. Conic sections are created when a plane passes through different points or parts of a cone. The first conic section is a circle, which is when a plane passes through a cone parallel to its base. A circle can be defined as all the points equidistant or the same distance from a center point. The equation of a circle with center HK is equal to x minus h squared plus y minus k squared, which is all equal to the radius squared. The equation of a line tangent to a circle at a given point is y minus the y value equals the negative reciprocal of the slope of the radius to the point times x minus the x value of the point. The next conic section is an ellipse, which occurs when a plane passes through a cone diagonally, not passing through its base. An ellipse can be defined as the additive distances from the two foci being equal for all points. The equation for an ellipse with center HK is as follows. X minus the h value squared plus y minus the k value squared, with the x value being over or being divided by the major axis squared and the y value being divided by the minor axis squared, which is all equal to 1. The next conic section is a hyperbola, which occurs when a plane intersects two opposing cones perpendicular to their bases. A hyperbola can be defined as all the points having a constant difference in distance between the two foci. The equation for a hyperbola with center HK is as follows. X minus h squared minus y minus k squared, with the x value being divided by the major axis squared and the y value being divided by the minor axis squared, all equal to 1. The last conic section is a parabola, which occurs when a plane intersects a cone through its base. A parabola can be defined as all the points equidistant from both the foci and the directrix of the parabola. The equation for a parabola with center HK is as follows. Y minus k is equal to 1/4 p multiplied by x minus h squared. conic equations can be written in the form of the formula above, with key values being A, B, and C. These key values A, B, and C are the important values in the discriminant using the quadratic formula seen below. If the values of A, B, and C are known, then by using the quadratic equation, specifically the discriminant, the specific conic section in which the formula represents can be discovered. To discover the conic section in which a function represents, sometimes completing the square is necessary. Starting with the equation ax squared plus by squared plus cx plus dy plus e is equal to 0, one can separate each of the variables into groups. To start the actual completing of the square, the c value and the d value are both taken and then divided by 2 and then squared to get the next value for each grouping section. Once these values are found, they can then be added or grouped with their specific and respective grouping. Remember that whenever you want to do something to one side of an equation, you must do the same to the other. So in this case, the c and the d values that were just added must be added to the other side. Once the squares are completed and the equation balanced, the groupings can then be factored. Once this is done, the equation can then be properly solved for. Once solved for, the conic section in which this equation represents will become apparent. Equations of two conic sections can interact in 5 ways: 0 solutions, 1 solution, 2 solutions, 3 solutions, or 4 solutions, depending on the section. One way to discover or find the intersections of two conic sections is through substitution. This is done by substituting one variable of one equation with values equal to that variable in the other equation. The second method of solving a system is by elimination. This is done by adding or subtracting the two equations to then make solving easier by canceling out certain values and variables.